Hi everyone. This is the first video for Pre-Calculus 11. And this will be Chapter 1. Polynomials. Alright, let's get started. The first thing we're going to discuss are the exponent laws that you guys probably remember from Math 9 and 10. If we have something like a to the power of n times a to the power of n, because they have the same base number, a, we're allowed to just add the exponents like this. So it would be a to the power of m plus n. If we have a to the power of n divided by a to the power of n, just like the first rule, because they have the same base, the answer is composed of the same base as well, and we're allowed to just subtract the exponents. So it's a to the power of m minus n. If we have something like a to the power of m to the power of n, we're allowed to multiply m times n. So it would be a to the power of mn. If we have a and b inside brackets multiplied together like this to the power of n, we're allowed to distribute this n to each variable. So the answer would look like this: a to the power of n times b to the power of n. Like that. Just like that rule, if we have a divided by n inside brackets to the power of n, we can distribute this m to both variables. So it'd be a to the power of n over b to the power of n. And that would be our answer. Anything to the power of 0, any number, any variable, it's equal to 1. If we have a negative exponent, like a to the power of negative n, we can actually rewrite this as 1 over a to the power of n. So you can rewrite this with a positive exponent, but it goes into the denominator, it gets flipped. If we have a fraction, like a over b to the power of a negative exponent, you're allowed to flip and replace the numerator with the denominator and the denominator with the numerator. So the b would come up, the a would go down, like that. And you can make the exponent positive like that. And with the distribution rule we learned above, you can distribute the n to both variables. It would be b to the power of n over a to the power of n. Okay, so let's just try an example. So negative 2x y to the power of 3 and everything to the power of 3 times x to the power of 2 times y over x times 2 to the power of y, and everything to the power of 4. Okay. So I think the first thing I'm going to do is get rid of the negative exponents. So let's rewrite this as 1 over negative 2 x y to the power of 3 to the power of positive 3 times. What we can do here is, because there's an x squared in the numerator and x in the denominator, we can cancel these out. There's an y squared in the denominator and a y in the numerator, so we can actually cancel these out like that. So it's actually x over y inside. So when you flip those, we get y over x. And then the negative exponent outside becomes positive 4. So now I'm going to distribute the exponents outside of the brackets and clean everything up. So 3 gets distributed to that negative 2, which becomes negative 8, to that x, which becomes x to the power of 3, and to that y. We have to multiply those two, right? So it would become y to the power of 9 times, distribute the 4, y to the power of 4 over x to the power of 4. Now, if we multiply these two together, 1 times y to the power 4 is y to the power 4. Negative 8. X to the power of 3 times x to the power of 4 is x to the power of 7 times x to the power of 9. Sorry, y to the power of 9. Now, because there's y to the power of 4 on the numerator and y to the power of 9 in the denominator, we can cancel these out. This would become 5. And our final answer would be negative 1 over 8 x to the power of 7 y to the power of 7. And note the minus sign being here or up here, or rewriting it so that it's just on the side there. All of these mean the same thing, so it's not different, okay? All right. So the next part, we're going to talk about operations with polynomials. So a polynomial in the variable x is an algebraic expression of the form a n times x to the power of n plus a n minus 1 x to the power of n minus 1 plus a n minus 2 x to the power of n minus 2 plus so on until we get to the end, a 2 x to the power of 2 plus a 1 x to the power of 1 plus a naught. So when we have a polynomial that looks like this, it looks a little bit complicated, but this term here has the highest degree. So the highest degree means n is the largest. So it has the highest power among all of the terms. The an in front of this term, this is referred to as the leading coefficient. Any number multiplied in front of the variables, they're referred to as coefficients, but this one with the highest power would be referred to as the leading coefficient. And this shouldn't be equal to 0. The n here represents the largest power among all of the terms in the polynomial. So n actually defines the degree of the polynomial. Okay. Note n here must be a whole number, which is any number such as 0, 1, 2, 3, 4, 5, 6, and so on until infinity. Okay? So no negative integers, no fractions, no roots, nothing like that. Only whole numbers are allowed. And the term a naught, the last term of the polynomial, this one right here, that's referred to as the term with degree of 0, and this is referred to as the constant. So when you have a polynomial that maybe looks like this number here is the constant. Okay, this is the leading term. 2 is the leading coefficient. And the highest degree term in this polynomial is 2, so the degree would also be 2. Okay? So The word polynomial is used to describe these expressions composed of numbers, variables, and exponents. The number of terms in the polynomial defines what we call it. So this one, there's 1, 2, 3 terms. We call this trinomial. When you have 2 terms, 2x plus 1, we call this a binomial. When we just have 1 term, we call this a monomial. Anything above 3 terms we just refer to as a polynomial. Alright, let's see. So we have rules for adding, subtracting, and multiplying polynomials. Let's start with adding. Look at this example. 2x squared minus 4x plus 4y minus x squared plus 2y plus 5y. When you're adding and subtracting polynomials, you're only allowed to add or subtract like terms. So like terms refers to terms that have the same variable and power. So something like 2x squared, negative x squared are like terms. They're both composed of x as the variable and the same power squared. If they have the same, or if they are like terms, you're allowed to just look at the front number of these terms and add or subtract them. So 2 minus 1 is equal to 1. So those two added together would result in x squared. Next, negative 4x and positive 2x are like terms because they're both composed of their variable x and the power 1. So if you add those together, you'll result in negative 2x. Finally, 4y plus 5y, like terms again, right? So they add up to 9y. So that's your answer there. Okay, so subtracting and adding is quite simple. Let's look at multiplication. So let's say we have something like x minus 2 times 2x squared minus 2x plus 3. Okay? When you multiply polynomials, you want to make sure you're distributing. So you do x times this, x times this, x times this, and then 2 times this, sorry, negative 2 times 2x squared, negative 2 times negative 2x, and negative 2 times 3. So let's do that one at a time. X times 2x squared is 2x cubed. X times negative 2x is negative 2x squared. X times 3 is 3x. Now you move on, negative 2 times 2x squared is negative 4x squared. Negative 2 times negative 2x is positive 4x. Negative 2 times 3 is negative 6. So you end up with 6 terms like this. Now you want to combine like terms. There's no like term that has x cubed, so we write that. Negative 2x squared minus 4x squared is negative 6x squared. 3x plus 4x is 7x. And then negative 6 is the only number, so write that there. So that would be our answer. Okay? Alright, so next we'll look at some special binomial products. Special binomial products. So you've probably already seen them before. You probably haven't called it this, but let's say you have something like a plus b squared. What does this mean? It means a plus b times a plus b. Like we learned above, we have to distribute this multiplication like that. So a squared plus ab plus ab plus b squared. This results in a squared plus 2ab plus b squared. Say you have a minus b squared. What does this mean? This means a minus b times a minus b. So if you multiply those, you get a squared minus ab plus b squared. So you end up with a squared minus 2ab plus b squared. So you're able to use this without actually distributing everything and calculating everything one at a time. Let me show you an example. So let's say you have something like 3x minus 2 to the power of 2. So this one, it looks a lot like this rule up here, right? So you take the first term, you square it, gives you, oh, what happened there? Gives you 9x squared. You take the first term, multiply it by the second term, and multiply it by 2, which gives us negative 12x, and then you square the last term. So negative 2 squared is 4. So you can get an answer like that without having to go, okay, 3x times 3x, which is 9x squared, 3x times negative 2, which is negative 6x, negative 2 times 3x, which is negative 6x, and then negative 2 squared, which is 4, and then adding like terms. You can skip that step and just go straight to here if you're using special binomial products. Okay. Another one you've probably seen before is a situation where you have a plus b times a minus b. So the terms look the same, but the sign in between them are different. So this can be rewritten as a squared minus b squared. Say if you have something like x minus 3 times x plus 3. You can rewrite this. Instead of multiplying everything out one at a time and adding like terms, you can do the first term squared, x squared, minus the second term squared, which is 9, just like that. Okay? The other way around, we call it difference of squares. So if you have something like a squared minus b squared, this is equal to a minus b times a plus b. So if you have something like 9x squared minus 4y squared, this would equal to 3x minus 2y, brackets, 3x plus 2y. Like that. Because you can rewrite this as 3x all squared minus 2y all squared. It looks a lot like what's up here, right? Alright. It gets a little bit more complicated when it's not just a square. So let's say you have a to the power of 4 minus a to the power of b to the power of 4. What do you do here? It's not a squared anymore. What you can do here is rewrite the first term as a squared to the power of 2 minus b squared to the power of 2. Now it looks like what we had up there, right? You can rewrite this as a squared minus b squared times a squared plus b squared. In terms of factoring, we're not done yet because this one we can't factor further, but this one, it looks exactly like the rule we have up here, right? For difference of squares. We can rewrite that as a minus b times a plus b, and then this as well to include in the answer. Okay? All right. So we're going to talk about factoring. Quadratic equations, all right? So let's say we have something like x squared plus 8x plus 12 equals 0. With the rules we know for factoring, we can rewrite this as x plus or minus something times x plus or minus something is equal to 0. The term we write here has to multiply to 12. So the possibilities are 1 times 12, 3 times 4, 6 times 2. And since the first term is both x, it doesn't matter which order we write this. So there's 3 possibilities here. The catch is that these two numbers have to add up to 8. So which one adds up to 8? This one. So that would be our answer. Because we're working with equations and this is not just an expression that we're factoring, we're not done yet. If x plus 6 in brackets times x plus 2 is equal to 0, if either one of these are equal to 0, the whole thing is just equal to 0. So for this equation to be true, we can say that x plus 6 is equal to 0, and this would give us a solution. So this would be equal to x equals to negative 6, right? If you put this back into the equation, it doesn't matter what negative 6 plus 2 is equal to. Our only area of interest is that negative 6 plus 6 is equal to 0, and 0 times anything is equal to 0, so that's a solution to the problem. The other solution is x plus 2, when that's equal to 0, x is equal to negative 2. So plugging in negative 2 into the equation again, just like negative 6 did, negative 2 plus 2 is equal to 0, and 0 times anything is equal to 0. So these would be our 2 solutions to the problem. Okay. Oh, another factoring method we need to talk about is grouping. So x cubed minus 4x squared plus 2x minus 8. So something like this, we can't factor it using the same rule that we used up here when we're factoring quadratic equations. We have 4 terms, there's a cubed term, the same rules don't apply. So for something like this, we're allowed to group these numbers like that. So we can factor them separately. So if we just look at x cubed minus 4x squared, we can factor out an x squared from each term, which gives us x minus 4 plus. We can factor out a 2 from both 2x and negative 8, right? When we factor that out, we get x minus 4. Notice how we have the same term multiplied to each of those now. It's x squared brackets x minus 4 bracket plus 2 times bracket x minus 4 bracket. So if we factor out an x minus 4 from each of these terms, which means just dividing each of these by x minus 4 and taking it out of the brackets. So by taking an x minus 4 out, we're left with these cancel, so x squared, and these cancel, plus 2, like that. And that would be our answer. Okay? Let's try a little bit more complicated example before we finish up today. So let's say we have something like x over 2 minus x squared minus 4 equals x over 2 minus 1 over 3. So in order to solve this one, I would want to get rid of the fractions first. So to get rid of the fractions, we're going to multiply this entire thing by 12. This would get rid of all the denominators, right? So the first term would be 6x. Second term would be 3x squared equals 2x minus 4. What I'm going to do here is move everything to one side. So everything here, I'm going to move it to the right side. That would give us 3x squared minus 4x minus 4 is equal to 0. If I factor this, we get 3x and x. Let's see. If we put negative 2 here, positive 2 here. Negative 2 and positive 2 multiply to negative 4. 3x times x is equal to 3x squared. When we multiply these two together, multiply these two together, and add these two together, that should add up to negative 4x. So in this case, it's 2x and then negative 6x. So that does add to negative 4x. Now, we're not done yet. Applying the same rule we discussed earlier, 3x plus 2 must equal to 0. And x minus 2 must equal to 0 for the entire thing to equal to 0. If you solve for x here, you get negative 2 over 3. If you solve for x here, you get x equals 2. Okay?